Hello guys, welcome back to the channel. So in today's video, we're going to continue with our introduction to SQL with MySQL tutorial series. So in today's video, we're going to be looking at data types. Okay, so I've been looking at from the very basics of SQL, how to write select statements. We move on to the different store procedures, views, CTEs, functions, variables. Now moving on to the data design. Well, in the last tutorial, we look at how to draw an ERD. In this tutorial, we're going to be looking at data types and in SQL, basically MySQL. Okay, so if you're new to the channel, please kindly consider subscribing to the YouTube channel, liking this video, and sharing this content with anyone who you think might find it helpful. So this channel is more about programming, Python, machine learning, data science, data analysis, and all that juicy stuff. So if you're interested in all those stuff, kindly consider subscribing, liking this video, and sharing this content with anyone who you think might find it helpful. Okay, so let's get started with this. So we'll be looking at numeric data types in this video. So the different numeric data types that we have in MySQL. So the different data types that we have in MySQL. So let's take a look at the different data types you have in MySQL. So there are mainly four different data types you have in MySQL. We have numeric types. We have string types or text. We have date and time types. We also have special types such as working with things like geometrics data and stuff like that. Okay, so we'll take a look at all of this each category under these data types, and we'll explore furthermore. Okay, so let's get into it. So we look at in this video, focus mainly on numeric data types, and numeric data types are divided into two main parts. Okay, so the first one being whole numbers, and the other one being floating point numbers. So the whole numbers, basically, you can think of them as integers. Actually, they're actually integers. So they're divided into into five main parts. So they're integers, they're big ints, they're medium int, small int, and tiny int. Okay, so each of these has their different use cases and different application. For floating point numbers, which are just decimal numbers, you can store numbers like 9.4, 9.5, 2.5, negative 23.5. So any pointing number is just under the decimal number, which consists of decimal, double, and float. And we'll take a look at all of these just in a second. So first of all, let's take a look at why different types of numbers. So why do we have different types of numbers? So we have integers, which are used to store whole numbers, right? If you want to store a number like 1, you need to use an integer. Why there's no point of storing 1.0, even though 1.0 basically is still 1 in mathematics, but there's no point of just having 1.0 or 2.0. That's like a waste of space, because to store the other pointing numbers, or even if it's a 0, it takes space in memory. So if you want to choose a whole number like 1, 2, 3, 4, 5, 23, 27, that's a whole number, right? You'll be looking at integers. So that we look about different types of integers, and the reason why we have different types of these integers is because of their size and how much capacity they can store. So for example, we have int, right? A tiny int. So tiny int takes only 1 byte of your storage in memory, and it can store a minimum value of negative 128 for signed values. Signed values means that they have a negative in front of it. So if you're talking about signed values, they have a negative or positive in front of it. Unsigned value, these are just positive numbers, and they move from 0 until the end of that capacity for that data type. But for negative numbers, for signed numbers, they can move between they have both negative and positive side, like both sides of the number line, starting from the point of 0. So with a signed value, a tiny int can have a minimum of negative 28, and a minimum value for unsigned of 0. Like it's unsigned, so it's just positive number. The lowest positive number is 0, right? Okay, and then for maximum signed value is 128. So move between you can think of this as a number line, right? So this is 0, so move all the way to negative 128, and all the way to 127 in the positive direction. Okay, so now if it is unsigned, right? Unsigned means that these are just positive numbers, so you can move from 0 to 100, 200, and 255, because if it's just a positive number, then it's just going to be going, its size is going to be double, because its size is not going to be distributed between both sides of 0 from the number line, right? So if it's just unsigned, then it's going to be from 0 until twice the size of the signed one, because it's only moving in the positive direction, while for unsigned is moving both in the positive and the negative direction, so it's distributed across, right? So yeah, so that's the difference between signed and unsigned numbers. Okay, so for byte, it takes a storage size of 1 byte. That's for tiny int. So if you're storing a number between maybe 0 to 255, like for example, we are selling products, right? And you only have 10 10 products or 10 different product lines, then you can use tiny int for that, because there's no point of using small int that takes 2 bytes and you don't need all. You're not going to have a product line of this amount of numbers, right? So the best option is just use a tiny int. Okay, that's just an example. Okay, so I'm not saying that should be the case all the time. So we also have medium int that's of 2 bytes. We also have int that's 4 bytes, and also have big int of 8 bytes. Okay, so you can see how all these values work. Okay, so I'm not going to go into depth about all this. Okay, so you can just think about what you're doing and decide which database to use. So let's take a look at the example, the example different types that they have used within our model classic models database. So let's go ahead and take a look at the payments. Okay, let's take a look at the order details. So let's click on this spanner button next to it, and it should it should bring you to this page. So now you should be able to see. So we can see the different data types. So order number is of type int. So int can have a maximum value of, let's say int can have a maximum value of this amount. So you could have this maximum value of about, I don't know how much is this. This is 1,000. This is about a billion, right? So a billion orders. So that's more than enough. You don't need to use a big int, because a big int stores obviously more values than that, and you don't need that. We also have product code, that's varchar. These are string types, and look at them just in a second. You have quantity order, which is also a type of int, and you also have decimal, which is floating number. And you can see order line can be like, maybe you have 3 different order lines in your company. So there's no point of using something like int that can store up to a billion values. Okay, so just use a small int in this case that can go until maximum of 65535. Okay, so that's a maximum value of a small int, and this is going to be unsigned, right? Because you only want it in the positive direction. There's no negative order line number, like it's only positive, right? So it is unsigned. Okay, so that's basically it for order small int. Okay, and for int type. Now let's move on to looking at decimal type. So decimal types there are mainly of 3 types, right? So they're used to store floating point numbers that have floating point on them, or like a point. Okay, so it consists of floats, decimal, and double. So let's take a look at floats. Floats has a size of 4 bytes, and its float does not actually store an actual value; it stores an approximate value. So for example, if you take a number like let's say a number that's very continuous, a number like pi, right? Pi is 3.14 and then continuous, right? So that's a very ridiculously, and it doesn't end, right? Nobody knows the end of pi. So if you try to store, maybe you're trying to do a scientific calculation and you want to store data in a database, then you can use a float for such situations, because you want an approximate value of pi. You don't want all the possible decimal place values of pi, right? So that's, you can use a float, because a float is just approximate value. It's an approximate value and not an actual value, and it only takes a space of 4 bytes. You also have double. Then double takes 8 bytes. It's also an approximate value, just like float, but it's more accurate than float, and also can be used in scientific cases. Okay, so if you're doing a scientific calculation and you need to store something that's a bit more than 4 bytes, you can probably go for double. And let's take a look at decimal. So decimal is 8 bytes, and it stores exact value. Okay, it stores exact value more accurately, and it's more accurate than float and double combined, and it is used for monetary values. For example, if you're storing values like in a financial, building a financial application, you want to even store, maybe it's a $1.5. You want to store that 0.5, because if you don't store that 0.5, you're going to have issues, because if you take 0.5 and it accumulates over a huge number of people, that's a huge sum of money, and you don't want to be messing around with that huge sum of money. So you want to accurately store that information as well, even if it's a point $0.005, then you still want to have that recorded. So you probably go for something that's more accurate and stores floating point numbers, and that's a decimal data type. And decimal data types, it takes two main things. So if you just say decimal, and it takes two main things. So the first one is the precision, and then the second one is scale. So precision most can be now between 0 to 65, and the scale is just, it can be now between 0 and 30. So precision basically says how many counts of numbers we can store. So for example, if I say decimal 6, means that if I count all the numbers inside, all the numbers or all the digits inside of this number right here should be 6. So we can say 1, 2, 3, 4, 5, and 6. Those are 6 numbers, and that's what the 6 represents. And then the 2 stands for how many parts of each should be decimal number. So I have 6 values or 6 digits, and out of it I want 2 decimal places. So it will be 4 actually be whole numbers, and 2 will be for decimal places. And in here we have 4 and then there's a comma, and then there's 2. Right, I forgot the comma there. So the comma will be for the decimal part, right? So I mean the 2 will be for the decimal part. So 2 will be for the whole number, and then 2 will be for the decimal part. But the whole number count should be 4, which is, that's what precision does. So precision about how many digits you have, and then the scale is about how many of those digits are going to be in the decimal part. Okay, so take a look at it. We can just go in here. You can see we have orders table, and you're looking at the price each column. So price is about money, right? It's about something financial. So we want high accuracy. So you can see we're going to allow 10 different digits instead of 10 possible digits, and then two of them will be for number, two of them will be for actually decimal place. So if I go ahead and actually look in this table right here, you can see I have for the price each, you can see I have two decimal places, 108.06, 167.06. So you can see all that are two decimal places, and that's what this represented. So this is just the design for this table right here, and you can see it's up here. So the decimal, which is the price for each, I can take up to 10 digits, of which two of them will be decimal places. Okay, so that's basically it for price each. Okay, so that's decimal, and decimal is used for mostly financial cases, while float and double like used for non like scientific calculations and other stuff like that, that you need an approximate value and not an actual value. Okay, so that's basically it for decimal numbers in this case. So in the next we'll be looking at string types, which are going to be textual data types. Okay, so if you're new to the channel and you enjoy this tutorial so far, you have been learning a lot from this series, please kindly consider liking the video, sharing this content, anyone who you think might find it helpful, and also subscribe to the YouTube channel. Okay, so if you want to help me further more increase my video quality, stuff like that, buy better equipment for video recording, you can support me by buy me coffee. The link is going to be in the description of the video. So thanks for watching. Again, kindly consider liking the video and subscribe to the YouTube channel if you haven't already. Thanks for watching, and see you in the next one. Keep safe.